So right now, is it audible and visible? Yes. Am I audible and visible to you guys? Do tell me, then only we can proceed the lecture. And in case you are new to the channel, do subscribe to this channel. It will help us and you as well. Yes, Daniel, am I visible? Okay. So I am waiting for your answers, then only I can proceed. Because it's an interactive session, right? So, yes, sir. Okay, so amazing. Now I am audible and visible to you guys. Okay, so with this, we will begin the chapter. Right now, what we have done, we have learned about the laws of chemical combination. We learned about what is mole, how we measure atoms and molecules in chemistry. Yes, and with this, we will proceed to the next part, that is application of mole. Because this, right, like I mentioned, this chapter is the foundation. Yes, this chapter is the foundation of chemistry. So if this chapter is clear, you won't be facing much problem in other chapters, because the questions will be in combination toward this chapter. Yes, so with this, let's proceed. That is the theme of our English channels. Yes, so you know Sumit sir, you already had the session with Sumit sir. Yes, how did you like it? The session with Sumit sir, amazing. And then right now is my session, and then after this class there will be a session with Krishna ma'am. So you do like all of us. If yes, then give us a like, do subscribe to the channel, do comment, and what topics do you want? Amazing. So again, subscribe, share and like. These are really important for us as well as for you guys, because this will help us to come in top of the search history in YouTube, and this will help to reach to those children who cannot afford this. Yes, this is a free services for those guys who don't have that much money to pay those to the coaching institutes. Yes, okay. So with this, let's begin. Again, in case you want to join our paid courses, you can use the code NS10. So you can use this code whenever you are subscribing to our subscriptions. In case this, you can use this code for 10% off. You will guys get 10% off the total fees if you are using this code NS10. Yes, okay. So with this, let's begin the topic, that is molecular mass. So in the last class, we had an idea about what is atomic mass. Yes, so atomic mass was how heavier an element is in comparison to the 1/12 the mass of C12 atom. Yes, so if an atom, let's say I am taking example of let's say oxygen. So oxygen is 16 times heavier than carbon 12 isotopes, and that too of 1/12 mass. So if that's the case, that was atomic mass if we are talking about atoms. So what if I am talking about molecules? So similarly, if atoms have some mass, it can be expressed in atomic mass and unified mass. Whereas similarly, molecular mass, for what about the molecules? Molecules can also be expressed. Yes, they also have some mass. So when I express the mass of molecules in terms of atomic mass unit, that is unified mass, it is called molecular mass. Is this thing clear? What is molecular mass? Basically, the masses, masses of some molecule. For example, let's say I have H2O. So if I have H2O and I am expressing its mass in unified mass or AMU, it will be called its molecular mass. The definition is same, that is, it is defined as the weight of a molecule compared to 1/12 of the mass of carbon atom. Again, similar to atomic mass, the molecular mass, the definition is still the same, but here we are talking about molecules, there we talked about atoms. Okay, so this thing is clear, amazing. So if I have to take the mass of, let's say, chlorine atom. So how many we had took the mass of chlorine atom? What was the mass of chlorine atom? So one chlorine atom, if I remember, one chlorine atom, the mass was how much? It was 35.5 U. It was mass of one chlorine atom. Right now, how many chlorine atoms are there in one molecule? In one molecule of chlorine, I am having 2 chlorine atoms. Yes. So 2 chlorine atoms will weight how much? 35.5 times 2. That is 71 U. So this 71 U, this is the molecular mass of this molecule. That is the molecular mass of chlorine is this much, 71 U. So mass of the molecule expressed in this unit, it is called molecular mass. Okay. So similarly, let's talk about H2SO4. So whenever we are talking about H2SO4 or any molecules in general, what we do? We basically take the individual masses of the atoms and then we add them and find the total mass. So in case of H2SO4, so what is the how many hydrogen do we have? We have 2 hydrogen, we have 1 sulfur and we have 4 oxygens. So I have to take the masses of all of these atoms. Yes. So what is the mass of hydrogen? It is 1 U, plus sulfur it is 32 U, plus oxygen it is 16, 4 into 16, that is this much atomic mass unit or unified mass. So if I am adding these total masses, what will be the final amount which I get? It will be equal to 98 U. So 98 atomic mass unit or 98 unified mass, it is the molecular mass of H2SO4. So is this thing clear? How to calculate the molecular mass of any molecule? You just have to calculate the individual atomic masses. Okay, sure. So this is how we will calculate the molecular masses. Next, this is the what they are saying. It is obtained by adding the atomic masses, just as we did right now, by adding the atomic masses of constituent atoms and expressing the figure in AMU. Yes, like we did here. That is 98 U. So I calculated the individual masses and I combined it and I found the molecular mass. Okay. So this is how we will find the atomic mass, molecular mass. Okay. So this question is for you guys. Do give it a try. Find the molecular mass of HNO3. So do try this. What you will get? Again, follow the same steps we did in case of H2SO4. Yes. So what we did was first of all we saw how many atoms are there. Let's write it down. That is, I am having 1 hydrogen atom, then I am having 1 nitrogen atom, and then I am having 3 oxygen atoms. Yes. So what I will do, these are the atoms, the constituent parts of the molecule. What we have to find the total mass, that is total mass of this molecule, which will be hydrogen has 1 plus nitrogen has 14 plus 3 times oxygen has 16. So if I am calculating this value, it comes out to be equal to 63 U. So again 63 U, basically mass of HNO3, one HNO3 molecule mass will be 63 atomic mass unit. So if I have to express this mass in grams, what will I do? I will simply write it as 63 times 1.66 times 10 raised to power minus 24 grams. So is this thing clear? This is how we will find the atomic masses as well as molecular masses. Okay, amazing. So this, I like this. Basically this is a very simple chapter, very interesting chapter. Just we need to be thorough with our concepts. Okay, so let's find this. That is, next is molar mass. So what is molar mass? Basically, like I had what? I had, let's say, I had HNO3. So what is this mass? 63 U. If I am finding the mass of one molecule of HNO3, it comes out as 63 U. But what if I have to find the mass of 1 mole of HNO3? When I am finding the mass of 1 mole of HNO3, this is something called molar mass. So if I am finding the mass of a 1 mole substance, then it is referred as the molar mass, and if I have to find the mass of 1 molecule, then it is referred to as molecular mass. So slight difference, molecule stands for 1, molar stands for Avogadro's number. Yes. So if what will the mass? It will be 63 times U times Na. Because if one molecule has 63 U, then Avogadro number will have 63U into Na. Yes. So a mass expressed in case of mass of 1 mole expressed in this is called molar mass. So let's find it. That is if the mass of the mole of molecules expressed in grams. Yes. So if I have to talk about, let's say, H2SO4. So if I am talking about H2SO4, what was the mass? The mass was mass of, let's say, 1 molecule of H2SO4. So it was 98U. Yes, we already found this. Now I am looking at the masses of how much? I am looking at mass of 1 molecule. That is mass of 1 mole H2SO4. Now it will be equal to 98U times Na. Yes. So if I am finding this number, let's find this number. That is, it is coming out to be 98 times 1.66 times 10 raised to power minus 24 times Na. Na is Avogadro's number, 6.022 times 10 raised to power 23. So and this mass will come in grams. So this is what I have to find right now. Now if wait just a second. Where was the slide? Yes, this is our slide. Okay. So if I have to find the mass of H2SO4, what we did was, good afternoon. If I have to find the mass of H2SO4, so mass of 1 mole, mass of 1 molecule of H2SO4, it was how much? It was 98U. Whereas when I am finding the mass of 1 mole, mass of 1 mole of H2SO4, it was coming as 98U times Avogadro's number. Now when I am calculating this value, let's see the magic, what comes. That is, if I am calculating this value, it is 98 times 1.66 times 10 raised to power minus 24 into Na. Na is 6.022 times 10 raised to power 23. Now this is the total value. When I am finding this number, let's use a calculator. If you are using your calculator and finding this value, you will see it will become exactly 1. Now this number on multiplication will give you just 1. So if it is 1, so what is the answer? It is 98 grams. Now look at the magic. When I am calculating the mass of 1 mole of H2SO4, it is coming at 98 grams. Grams, you look at the unit. Whereas when I am looking at the mass of 1 molecule of H2SO4, it is coming at 98U. So the number is, the numerical value, it's same. Whereas the units are different. So this is why we use the Avogadro's number and the atomic masses as these values, so that our calculations becomes simpler. Yes, so this is how we will do these type of questions. So when I'm talking about the molecular mass of H2SO4, it will be 98, but the unit will be U. If I'm talking about the molar mass, it will be 98, but the unit will be grams. So this is what they have written. Numerically, molecular mass and molar mass would be the same. And similarly, the mass of 1 mole of molecules expressed in grams, it is the molar mass. So I hope this thing is clear to you guys. Yes, okay. So let's proceed. So this is the question for you guys. We have to calculate the number of moles of H2SO4 in 392 grams of H2SO4. So how can we solve this example? Let's take an example. Let's say I will give you a formula. I will help you. Okay. So what is the formula for this guy? Let's say N is the number of moles. So we have already done one formula for number of moles, which was number of identities divided by Avogadro's number. Let me write it down. It is number of entities divided by Na. So this formula we have already done in the last lecture. Right now I am giving you one more formula, which will be given mass divided by molar mass. So this is our new formula, that is given mass by molar mass. It will also give you number of moles. Why? Because let's say I have 98 grams of H2SO4. So how many moles of H2SO4 do I have? I have 1 mole of H2SO4. Yes, for 1 gram, 98 grams, I have 1 mole. So if I double this amount, that is for 196 grams. How many moles do I have? I have 2 moles. Similarly, so and so on. So basically, if I am dividing the mass, given mass, by total molar mass, then what I am getting? I am getting exactly, yes, the number of moles. So let's find it out. That is, what is the given mass? Given mass is 392 grams divided by, what is the molar mass of this? It is 98 grams per mole. So 398 divided by this, it will come out equal to exactly 4 moles. So this is how we will calculate the number of moles in case mass is given. It can be atomic mass in case of atoms. It will be molecular mass in case of molecules. Yes? Okay. So this is how we will calculate these type of questions, and the answer will be really simple. You won't be facing any problem as such. Okay? Sure. So let's proceed towards the next question. Now this is a big question. This is something where I have taken 4 questions at one go. Now this question will help us to revise all the concepts which we have done till in this class as well as in the previous class. So if anyone is able to solve this question on his own, he has understood every part of my lecture. Yes, so you guys do try this question. Let's see how many of us can solve this. Okay, so I will help you. What they are asking? They are asking, what I have is, I have 784 grams of H3PO4. Right now I have 784 grams of H3PO4. Okay, so what they are saying is, calculate first of all the number of phosphorus atoms. How many atoms do I have in H3PO4? First point. Second, they are asking number of electrons. So total number of electrons in this molecule, and how much molecule? How many molecules? 784 grams of molecules. Yes. Similarly, they are asking for number of moles and number of atoms. Yes. So how to solve these type of questions? Let's start with a roadmap. What will be the idea when I am looking at this question in my first attempt? So whenever I look at this type of questions, what strikes me initially is what I have been given. I have been given the total mass. So what I have is, I have total mass in this case. So what we can find from total mass? Right now we had the formula total mass divided by molar mass. What does the quantity is? What is the quantity? It is number of moles. Right now, yes. What is number of moles? It is total mass divided by molar mass. So if I have total mass, I can calculate number of moles. How? I have to divide this by molar mass, and then what I will get? I will get number of moles. So once I have the number of moles of the molecules, then all the values will be easily derivable. Yes. So just the idea is, look for number of moles. Whenever you face any question of mole concept, try to find number of moles in the first attempt. Yes. So in this case, is molar mass given? Molar mass is not given. So our first step here would be to find the molar mass. So for molar mass, I have H3PO4. So I will have 1 into 3 plus phosphorus is 31. They have already given the value, plus 16 times 4. So this much of grams per mole. This is the molar mass. So if I find this value, it will be equal to 98 grams per mole. So first step is done, that is find the value molar mass of H3PO4. Okay. So first is done. Next what they are asking is, next they are saying find total number of phosphorus atoms. Okay. So at this moment I have number of molar mass. What I will find in next step is number of moles. So if I have to find number of moles, here I am using the formula. Number of moles is total mass, which is 784. So 784 grams divided by molar mass, that is 98 grams per mole. So if I am finding this value, grams and grams get cancelled, the answer will come in moles, and I guess this value is close to 8. So how many moles of molecule do I have? I have 8 moles of molecule. So at this moment I have 8 moles of what? H3PO4. So I have 8 moles of H3PO4. Now what they are asking is number of phosphorus atom. Now what we will say? We will say in one H3PO4 molecule, I have how many phosphorus atoms? I have one phosphorus atom. So if one H3PO4 molecule has one phosphorus atom, the question is simple. Using unitary method, give me the answer to, if I have two molecules of H3PO4, how many phosphorus atom would be there? There would be two phosphorus atom. If there are three molecules, three. And if there are Avogadro's number of molecules, there would be Avogadro's number of phosphorus. So similarly, how much we are looking at? We were looking at 8 moles. So if there are 8 moles of H3PO4 molecules, then I would have 8 moles phosphorus atom, simply using unitary method. So in case of, let's say this is part A. So how many phosphorus atoms are in total we have? We have 8 times Avogadro's number, that is Na phosphorus atoms. So this is the answer to part 1 of the question. Yes? Okay. So this is the answer to part 1. Yes, you guys have to share this session as much as possible so that it can reach to every nook and corner of this country. Okay? Yes. So next, let's look at part 2. Part 2, they are asking for total number of electrons. So if I have to find total number of electrons, first of all, what I need to do is I have to find how many electrons are there in one molecule of H3PO4. Okay? So if I have to find in one molecule, again, second part is find one H3PO4 molecule has how many electrons. So I have to find number of electrons. So hydrogen, there are 3 hydrogen, and in one hydrogen there is 1 electron. So total 3 electrons in hydrogen plus phosphorus. How many electrons in phosphorus are there? The atomic number is 15. So 15 plus oxygen, it's 8. So 8 into 4, that is 32. So 32 plus 3, 35 plus 15, 50. So total I am having 50 electrons in one molecule. So one H3PO4 molecule has 50 electrons. Now what we have to find? We have to find total number of electrons. Similarly, I will use unitary method. Hence, 8 moles H3PO4 molecule will contain, using unitary method, it would be 50 times 8, these many moles of electrons. So what is this value? This is 400 Na electrons. So this is how we will find the answer to the second part. Yes? Okay. So 2 parts are done. This part is done and this part is done. Now the third part. We have to find number of moles of hydrogen atoms. So look at this. We have to find total number of moles. They are asking for moles, not the number of atoms. Yes. So if they are asking for only the moles, so this is very simple. Because I know one H3PO4. Again, let's write it down. That is third part. One H3PO4 molecule. It contains 3 hydrogen atoms. Yes. If one H3PO4 contains 3 hydrogen atoms, then the question to us, you guys, is what was the total amount of these H3PO4? We had 8 moles. Yes. So 8 moles H3PO4 molecule, they will contain how much? 3 times this, that is 8 into 3, these many moles of hydrogen atoms. So the total answer is here 24 moles. So 24 moles of hydrogen atom are present in this. So this is how, when will you do atomic structure and will you cover all the topics in that chapter? Daniel, atomic structure will be the next chapter in this series, and we will cover each and every topic. So you don't worry, it will be done. But first of all, mole concept will be done because this is the foundation chapter. Once this chapter is done, then we will proceed towards atomic structure. Once that is done, then I guess accordingly we will follow the sequence of NCERT. Yes, there can be a change in the topics. First topic will be done, maybe the first topic in NCERT is done in my 3rd or 4th lecture. But topics, all the topics will be covered. Okay, sure. So this is the answer to part 3. So this part is also done. Okay. And in the last part, they are asking number of oxygen atoms. So again, using unitary method, the fourth part is, I know one H3PO4 molecule. It contains 4 atoms of oxygen. Yes. Now, how many H3PO4 did I have? I had 8 moles H3PO4. So, how many oxygen will they contain? They will contain 4 into 8 times Na. These many atoms of oxygen. Now, what is this value? It will be 32 Na atoms of oxygen. So, this is the answer towards my last part. That is, hi Vijay, hello. So, this is the answer to the last part. That is 32 Na atoms of oxygen are contained. So, this question is really important. Let's star mark this, because if this question is clear, all the concepts till this part are clear. Okay. Thank you. Amazing. So, do go through this question. Once the lecture is complete, do solve this question again on your own without looking at the solution. So, this will really help you. Okay. Amazing. So, let's proceed. Then, looking at next topic, that is gram atomic mass. Now, what is the difference between atomic number and atomic mass? Is these both are different? Yes, Daniel, atomic number and atomic masses, they are different, because atomic number is what? Let's take an example. Let's say, I have please space. Yes. So, let's take example of, okay. So, let's take an example of oxygen. So, oxygen, what is the atomic number of oxygen? Oxygen atomic number is 8. So, what does the atomic number tell me? It tells me exactly the number of protons, yes, or number of electrons in neutral molecule. Amazing. And if I have to talk about its atomic mass is exactly total number of protons plus number of neutrons. So, this comes out in case of oxygen as 8 plus 8, which is equal to 16. So, 16 is the mass number or atomic mass of oxygen, whereas the atomic number is 8. So, I am hoping, Daniel, this question is clear. Yes. So, let's proceed. Then, okay, the gram atomic mass. Now, gram atomic mass, this terminology is present in the older times. Yes. So, during the older times, we used to have this gram atomic mass. So, basically, it is nothing. Right now, you are thorough with the molar concept, right? So, if I am talking about molar mass of anything, you are clear with it. Yes. So, if I write, let's say I am writing 1 gram atom of oxygen. If I write it as this, 1 gram atom of oxygen, it is nothing. But whenever you find gram atom, replace it by mole. So, 1 mole of oxygen. That's it. Basically, expressing mole in different unit, fancy way. It is just a fancy way to write mole, nothing else. So, you just have to find wherever gram atom is there, replace it by mole, and everything else remains the same. Yes. So, you won't be facing any problem at all. Okay. Sure. So, let's proceed. Next it is, so what is the difference between 1 gram of oxygen atoms and 1 gram atom of oxygen? Now, this is where many of you guys face a problem. So, I have included this question because this is something which I have been asked again and again in my classes. So, I have already taken the question. So, is this right now? This might be a question in your mind as well. What is the difference then between 1 gram of oxygen and 1 gram atom? So, there are two things. First is 1 gram of oxygen atoms, and next is 1 gram atom of oxygen. So, first let's look at the second part, that is gram atom. Now, gram atom is nothing, it is just mole. Like I told you, that is 1 mole of oxygen. So, 1 mole of oxygen, and we know what is the mass of 1 mole of oxygen? It is 16 grams per mole. So, this we have already done. So, 1 gram atom of oxygen simply means 1 mole of oxygen. Yes. Whereas in case of 1 gram of oxygen atoms, this simply means we have 1 gram of oxygen atoms, nothing else. Here the total mass of atom is just 1 grams. So 1 grams of oxygen is present in this case, whereas 16 grams is present in this case. So this is a slight difference between the terminology. Again, this was used in the older text. Right now we are only using mole. Maybe you can find this in some books, but just to be clear, this is not used anymore. Okay. And similarly, there is a terminology behind gram molecular mass. Again, if I find it as 1 gram molecule of, let's say, water. So again, you can replace gram molecule by what? You can replace it by mole. So I have 1 mole of water. Now what is 1 mole of water? Again, this is equal to 18 grams per mole. So basically, 1 mole of any substance can be replaced by 1 gram atom or 1 gram molecule of that substance. If the substance is atom, it is gram atom. If it is molecule, it is gram molecule. Nothing else. Just a fancy way to write. Okay? Sure. So let's proceed towards the next part. That is, right now, all the questions which we attempted, what were they? All the questions, they were simply based on the masses. Daniel, exactly what is formula mass? Okay, let me help Daniel in this part. He is asking a simple question. Basically, he is asking what is formula mass. Actually, I had to take this in next lecture. So I am just giving you a hint because this topic will be done again. Yes. So in formula mass, what the concept is, basically, let's take an example of NaCl. So if we are talking about NaCl, the salt, the common salt, NaCl, the sodiums and the chlorines, they are not individually present. In NaCl, if I had one Na atom, Na ion, so Na cation will be surrounded by, because this is ionic, so it will be surrounded by 6 chlorine anions. Yes. Similarly, each chlorine will be surrounded by 6 sodium cations. So basically, there is not an individual identity. Let's, for example, take water. So water was an individual molecule. Whereas when I'm talking about some atom like NaCl, NaCl is a crystal where there are thousands of sodium present and thousands of chlorine present. So if I have to talk about individual identity like water, H2O just is a molecule. There is an individual identity, whereas in case of sodium chloride, there is no individual identity. So what is something which is repeating again and again? So in case of sodium chloride, NaCl unit, now this unit is repeating itself again and again. So when a unit is repeating itself again and again, we call this thing as formula unit, and the mass of this is called formula mass. So I am hoping this is clear. We will take this again in case this is not clear. Okay, so mass of NaCl, if it is 58.5 U, so this 58.5 U is basically the formula mass. Basically, the building block of any crystal. Yes, so it's clear to Daniel. Okay, Daniel, amazing. So let's proceed. So what I was talking about was, right now, all the things which we took, we took basically solids, and even if we talked about some other liquids, we talked about basically their mass. The masses were given in general. But what if in some questions the masses are not given? For example, in case of, let's say, liquids, the masses are not given generally. Let's say, for example, we are taking milk. So when you are taking milk from a vendor, you guys are talking in terms of its volume. You say, give me 1 liter of milk, give me 500 ml of milk. You are not talking about in kilograms. So basically, usually the liquids are mentioned in volumes. Yes, the volumes are mentioned and not what? Not the masses. So in cases of liquid, what I am telling is, in liquid, generally volumes are specified. Whereas in case of solids, the masses are given. Yes, so in case of solids, masses are already given. But in liquids, the masses are not given. But I have to talk about masses because using the mass, I can find the number of moles. Because in end, what is the end result? I have to find number of moles somehow. So for number of moles, I need masses. So for masses, right now what we are given? We are given volume. So what we can do in case of liquid is we can use a formula simply, that is density is mass by volume. Yes. So from here what will be the mass? Mass will simply be equal to density times volume. So in case of liquids, what will be given is the density as well as the volume. So density and volume both will be given in case of liquids. Yes, is this thing clear? Okay. So for liquids, what will be the roadmap? In liquids, we will have to from volume and density, these both will be given. So once these are given, you will find what? You will find the mass, and from there you will find the molar mass. Okay? Yes. So let's take a question on this same concept, that is calculate the number of electrons in 9 ml of water given the density of water is 1 gram per ml. So what we are given? We are given the volume and we are given the density. So density as well as volume both are given, and the masses, atomic masses are given, which we already know. I am just giving for the safety point. Yes, these won't be given mainly. These are just for your understanding, for your reference. Okay. So how to proceed these type of questions when the volumes are given? So again, we are clear with the roadmap. What was the roadmap? Roadmap is simply, we will look at what? We will look at the, we have to find somehow the number of moles. So what we are given? We are given the volume. So what is the volume of water? It is given as 9 ml. And what we are given also? We are given the densities. So density of water is, it is how much? 1 gram per ml. So using density and volume, what I can find is, using density and volume, I can find mass. That is, what will be the total mass of water? So total mass of water, it is density times volume. So density times volume, it is the total mass. Hence density is 1 gram per ml divided into volume is 9 ml. So ml and ml gets cancelled. The mass is coming out as 9 grams. So this is the mass, total mass of water given. So from mass, what I can find now? From mass, I can find the molar mass. Yes, I can find number of moles. So how we can find number of moles? So number of moles is given mass divided by molar mass. Yes. So what is the given mass? Given mass is 9 grams and molar mass is 18 grams per mole. So grams and grams get cancelled. It is coming out as 0.5 mole. So how many number of moles do I have? Right now I am having 0.5 moles. Is this thing clear? So total 0.5 moles I have. So what we have to find? We have to find number of electrons. Okay. So for this, we have to look at how many electrons do one molecule of water have. So if I am talking about one molecule of water, how many electrons do I have? I have 1 in a hydrogen and 2 hydrogen are there. So 1 into 2 plus in oxygen there are 8 electrons. So this will be plus 8. So total 10 electrons are present in one molecule of water. In one molecule there are 10 electrons. So how much water we had? We had 0.5 moles. So in 0.5 moles of water, then how many electrons will we have? Simply unitary method, we will have 0.5 times 10 times Na. These many amount of electrons. So what is this number? 10 by into half, that is 5 times Avogadro number of electrons. So this is how we will find the total number of electrons in case of this molecule. Is this thing clear? Yes? Okay. So if this thing is clear, we can solve the next question, that is calculate the number of electrons in 16 ml of CCl4. Again, this is just the same type of question. What we need to do is simply from volume and density find the masses, and from masses find the molar mass and divide the molar mass and find the number of moles. Once number of moles are there, calculate number of electrons in one atom and one molecule, and then you will find the answer. Same steps, exactly same steps. Yes. So let's start with this. That is, what is the volume of CCl4? So volume of CCl4, it is given as 16 ml. And what is the density of CCl4? So density of CCl4, it is equal to 0.9 grams per mole per ml. So what is the mass of CCl4? So mass of CCl4, it will be density into volume. Yes. So it is equal to 16 ml times 0.9 grams per ml. So ml and ml get cancelled. 16 into 9, I guess 14.4 grams. So this is the total mass of CCl4 which I have. Okay. So if this is the total mass of CCl4, so what I have to look at? I have to find number of the molar mass. Yes. And divide this by molar mass. So what is the molar mass? So if I have to find number of moles. So number of moles would be given mass, which is 14.4 divided by the molar mass. Is the molar mass given? No. So we have to calculate, that is 12 plus 35.5 times 4. So this is the number of moles of CCl4 which we have. Yes. Now after this, what we will do? We will say in one molecule of CCl4, how many electrons are there? In one carbon, there are 6 plus chlorine, 17 times 4. Yes. So these many amount of electrons, which is coming out as 74, I guess. Now in one molecule there are 74 electrons, and how many moles we had? Similarly, let's say I am having Y moles. So if there are Y moles of CCl4, again the same steps. So Y, the answer would be Y into 74 into Na. This is my total number of electrons. You have to do the calculations part. I am skipping that as for now. Yes. And this is how we will solve these type of questions. Now, is this thing clear? Now, this is very, very important. Once this concept is clear, you can solve all the types of questions related to this. Yes. Amazing. So with this, let's end the session right now. We have at least understood many different aspects of mole. So how we're using the mole concept? This is how we're using. We just have basically what it is. It is just unitary method. Fancy way of applying unitary method is called mole concept, nothing else. So you just have to be thorough with your concepts, and this chapter will be a cakewalk. Yes. So with this, let's end the discussion. Thank you for joining me. You can still share this session to those guys who actually need this, so that they can also get the full benefit. Okay. So do subscribe, do like. Thank you for joining me. This is your Nikhil sir signing off.